door is almost snowed in by this drift here. I measured a non-drift total of about 10 inches today. Got to be careful not to measure snow drifts. For example, the best place to measure snow is an open field away from any obstacles, preferably. But sometimes if you get a wind-driven snow, that will tend to keep accumulations down because a lot of the snow gets blown around into drifts. Usually for that kind of storm, you want to like have a funnel that will funnel the snow into a basically a funnel, and that will more accurately measure precip. We got around 10 inches of snow from this event last night. Basically what happened was, even when you were having sleet coming down from a loft, what was happening was you had a very thick layer of cold air below the warm tongue where you had very high humidity values of 100%. We had humidity values of 100%, which basically is thick clouds for about 8,000 feet up to the warm tongue. So you had clouds from about 1,500 to 8,000 feet. And this caused snow formation from below the warm tongue. That is why when you had heavier precip on radar, you were having sleet coming down, but when you weren't having anything intense on radar, when you're having nothing streaming in from the southwest, you were getting snow. The thing is, the models did not forecast that. So that is why the NAM, which was only forecasting a few inches of snow for New York City, got a lot more. We got a lot more than some of the models showed. So the National Weather Service was correct in their analysis for 8 to 12 inches of snow because they were kind of anticipating that lower elevations, that lower level snow. Maybe they weren't anticipating it, but their forecast did verify, and we did get a lot more snow than I anticipated. Especially, I was thinking that could happen, but the models were anticipating that the changeover to sleet would not happen, which is what I disagreed with. However, we did transition over to sleet briefly, but it was never all sleet. There was always snow mixing in with the sleet. Even during the transition, there was snow coming down. Even when we were having heavy sleet and even had some lightning, there was snow coming down with the sleet, which, as a result, was because of convective activity from where the warm tongue was. So you basically had elevated convection. Hold on, I'm just gonna share the stream. Well, thank you for joining me. Oh, thank you so much. Thank you, Kuta. Thank you so much. Eche. Thank you, Kuta Eche. Thank you so much for joining. So we ended up getting 10 inches of snow. We're about 22 centimeters of snow here in New York City. Those who use the metric system. So this is roughly how much snow we got. So this says 6 inches, but of course there was a lot of melting since initially the snow did not accumulate because the ground was too warm. It almost immediately accumulated on the grassy surfaces or on the ground, like the mud and dirt. You had almost immediate accumulation. Totals ranged from 2 feet. Totals range from like 5 inches, like right along the shore, to about 12 inches in some parts of the city. Like Bronx got about at 12 inches, and there was one report from Jamaica that said 11.5. I kind of think that's a little too much, but it's possible as there was some higher reflectivities on radar around Jamaica. So it's possible that once the cold air came in, that more intense stuff on radar was actually heavy snow. In fact, when I thought there was going to be sleet, the air was already cold enough for heavy snow. In fact, after the sleet changed over back to snow, the visibilities got really poor and were around a quarter of a mile. I could not see past a few blocks. even though there was nothing much impressive on radar, there must have been some lower level convection or snow, and combined with snow from higher up to make it more heavy. The temperature right now is in the upper 20s. The high forecasted for today was only 31 degrees. So yeah, it's very messy, as you can see. And here's the thing, we haven't even hit climatological winter. That's still in about 4 days. Today's the 17th. First day of winter is on the 21st. So we're still technically in fall. So you can consider this, even though this is a winter storm and we are in December, the first day of winter has not come upon us right now. So technically, you can say that this is a late fall, early winter storm. But we are in seasonal winter, not in climatological winter. I mean, we're in climatological winter, not seasonal. Seasonal winter is when you have the equinox. We haven't had the winter equinox yet. So we're in climatological winter, not seasonal. Or, sorry, I got confused there. We are in climatological winter, but not seasonal. Seasonal winter refers to when you have winter due to the equinoxes, based on where the position of the sun is. The snow that we had largely came from this ocean storm. The reason we didn't get as much snow or as much precip was because most of your convergence occurred further inland. So most of your convergence occurred away from the coast towards the areas around Bennington, where close to 4 feet of snow came down. Bennington got close to 3.5 feet of snow. Some areas got close to, numerous locations in the Bennington area got over 3 feet. So that forecast I called for 2 to 3 feet of snow completely verified exactly where I anticipated, in the inland areas of the Northeast. I knew there's some areas we were going to break their snowfall records, so yeah. This winter storm is not the worst I've seen. You know, I've lived in New York City my whole life. The worst winter storm I've seen thus far had to be either the 2006 storm, which had a lot of thunder snow, or the 2016 storm, which had a lot of wind and very heavy snow. I also remember the President's Day storm was pretty bad, but it wasn't the worst. President's Day storm of 2003 was pretty intense. I mean, this is the worst storm I've seen since the 2017-2018 winter, but there's 2 planes. There's one plane over there that's making noise. There's another one just above me right there, and there's another one. So there's literally 3 planes just within my viewing range. Okay, anyway, measuring snow again. So we definitely got quite a bit of snow yesterday. And I got quite a bit more than I anticipated. I mean, I anticipated only like 5 to 6 inches. I thought we were going to almost immediately transition into sleet, and that was going to be it. Hold on. It's probably in the mid-20s right now because the thing that's getting stuck to my ruler is freezing over. Yep, we got about 10 inches of snow. I mean, this area doesn't usually get a lot of wind, so yep, just about 10 inches. So usually the more accurate places is to measure where the snow would like pile up, but not because of wind. This area doesn't usually get that much wind. Yep, not that much. There's been a lot of, like, you clearly don't want to measure that area because that's just been shoveled up. When you want to get your highest amount, you don't want to measure drifts. Like, there are some people who say, oh, I got 50 inches of snow, when you actually only got like 20 or 25. Some people want to measure drifts because they want to stand out and get the biggest amount. You're not supposed to do that. For example, your best bet is to measure an open source of land, or to have a narrow protected area where a lot of snow can fall in. For example, there's a lot of wind here. This is a big open space. You're going to have a lot of wind. So you don't want to measure like against anything. So you want to measure further from the surface. Nope, not there. All right. Seems like not a lot of snow came down here. This is not a good place to measure because of this openness. There's a lot of wind that comes through here. So your snowfall amount might not be so accurate. So, also this area is kind of protected and it gets a lot of wind here. So, my grandmother's backyard seems to be like a pretty good area. Oh, my hands are killing me. And I don't mean this place. Okay. Let's see. I've measured amounts here in this yard over 1.5 feet before. The most snow I ever measured here was like a little bit over 20 inches. That's ever. But the thing is, here you might only see a little bit of snow. 7 inches. Total, I got 10 inches. I'm trying to measure other areas because, let's see. This area hardly ever gets any wind, so it's a pretty good area for measuring actual. Nope. I don't know why this area got so little. There's a lot of sublimation here. See? Yeah, everything feels hard. See? But we didn't get any rain though. See? We didn't get any freezing rain, but the thing is, there was definitely some sublimation where measured was more in the shade. Yeah. There's very little wind here, so maybe, yeah, some of the snow got bypassed here. And not everything here came down. So like this area might have got more sleet than snow because it's not as protected. it means it's more protected. Also, you get a lot of sun here. So this whole area would get sunshine. So there'll be definitely some melting. And where I measured was sheltered. So maybe it's better if I measure on the other side that's more sheltered from the sun. Because the snow, as you can see, there's some evidence of melting and refreezing here. Same here, see? You can see how crunchy the snow is. Evidence of melting and refreezing. And you see the snow perched in the trees. That's from the second round of snow that came from last night. So the thing is, you got a lot of sun here. So you might want to walk to the other side to get a more accurate measurement of snow. For example, these sheltered areas on the other side would have little to no sun because the sun passes to the south. So like this area would get a lot less sun. See the snow here is drier. So it's less likely to freeze and refreeze here. I mean, to melt and refreeze. And when I was measuring in that yard, the snow was dry and fluffy. There was no evidence of melting and then refreezing of the surface. Here, as you can see, there's closer to 10 inches, especially on this side that will be given less sun, for example. Here, you'll probably get the same amount. So you can see the surface here. It's weird. Okay, I'm gonna have to go in a couple minutes. 9 inches here, see? So, as you can see also over here, so you do see like a yeah. For some reason this area always gets a lot less snow. But that backyard I measured, that was more sheltered, got closer to 9 inches of snow. Sheltered areas usually better with snow, but here you get a lot of wind, especially in this little street. Plus we're getting an east wind, so there'll be a lot of blowing and drifting here. So Not the best area for measuring. A lot of drifting over there. And on top of this, okay. See all this solid ice here? As you can see here, good amount of drifting here. Not a good place to measure. I mean, you could argue that the snow is coming down, that there was better accumulation, but look, here you measured almost 11 inches of snow. That's drifting. That's definitely drifting. So you want to find a sheltered area, preferably. Sometimes snow could pile up. That could be, doesn't always mean it's a drift. Sometimes that's where the snow is more angled and it would fall more accurate, like has a better chance of coming down because of how the wind is angled. But you want to avoid those two. You want to basically, for example, snow is different from rain as it doesn't fall straight down. If there's even a tiny breeze, it'll be blowing sideways. With rain, you need a significant amount more wind because rain is more dense, water is more dense than ice crystals. So ice crystals blow around easier. So you can see, basically, I'm going to demonstrate my point just by tossing it in air, and you'll see how it floats. Snow is a lot more, how to say this, lighter in an area than rain. Because snow is very light and fluffy, and it takes a lot more energy to move an ice pellet or a raindrop than it takes to move a snowflake. Snowflakes hardly require any energy, and even the slightest breeze will cause them to move sideways. Even when you have light 5-mile-an-hour winds, snow will be moving at an angle where rain will be coming down straight. That is why snow is very hard to get uniform and it's subject to the wind. That's why you get blowing and drifting snow. Snow is like sand. It can blow, it can drift into drifts, just like sand does. And if you want to get an actual amount of snow, actually how much came down, the only way you can do that is by setting up a device that can put snow into a funnel that is wind sensitive. Weather stations often have that, and that's how they're able to accurately measure how much snow comes down in a particular area. Usually, if you don't have these, you can have one area of flat ground say, oh, I only have an inch, and another area on the ground. So you have 3 feet of snow, 4 feet. Like, for example, here, you can actually see grass over there. See, there's grass. And yet over here, there's quite a bit of snow. I just want to show you something, guys, something cool. You see that little dot right there? That's planet Mars. Doesn't look as bright as it did a few months ago. That's because it's not as close now as it was back then in October. This year will be pretty snowy. I already anticipated 40 to 60 inches of snow for New York City this winter. The primary reason I am forecasting so much snow is because we have a negative NAO or neutral NAO right now. We have warm waters in Labrador. We have a La Nina. And also, the Northeast Pacific Labrador isn't necessarily that cold. And also the PNA has been trending positive the last few weeks. So all this going together is signifying that this winter could be pretty cold and snowy. So my forecast for this winter is, as I said, 40 to 60 inches for New York City, 60 to 80 inches of snow for Boston, and for Worcester, about 80 to 100 inches. And from Binghamton, well, considering they already got 40 inches of snow, I'm forecasting about the same amount, 100 inches of snow. The thing is, Binghamton, actually, for Binghamton, I'm going to forecast 140 to 160 inches of snow, because with La Niñas, you're going to get a lot more storms in the East Coast. So you're going to get a lot more storms being forced up the coast, especially inland runners. Those are common during La Niña events. So for Binghamton, I'm forecasting Binghamton, very snowy winter, could be record-breaking. I mean, I already suspect that this storm shattered all their previous snow records. They had over 40 inches of snow, and the thing is, almost all that snow fell after midnight. They got literally snowfall rates of 5 to 6 inches an hour in Binghamton. It was incredible. They literally had 13 inches of snow in only 2 hours. That's a snowfall rate of 6.5 inches an hour. In 2 hours, they had snowfall rates of 6 to 7 inches an hour, but there was no lightning with the activity. It was just really heavy snow. And the temperature was 15 degrees, so you had a very high snowfall water ratio. So Binghamton is going to get a lot of snow this winter. They're going to get several big storms. Not every storm that gives New York City a lot of snow, not every storm that gives Binghamton a ton of snow will give New York City a lot of snow. For example, you can have rain in New York City and 3 feet of snow in Binghamton, for example, or 2 feet or a foot. And not every storm that goes right up the coast and gives New York City a lot of snow will give Binghamton a lot of snow. But you will get a lot of inland runners. You get a lot of storms that go up the coast. Very often during La Niñas, you get storms that will make sharp turns, sharp curves up the East Coast, may even stall out, like this one almost did. Didn't stall out though, but it came close to doing so. This storm gave New York City about 8 to 12 inches of snow, roughly. So this storm definitely beat a lot of my expectations. And the National Weather Service was very close with the accuracy of their forecast. Oh, jeez. That guy's insane. He's just asking for an accident. He was driving a Jaguar. One of those high-powered Jaguars. Right here. Again, you had a lot of sublimation and melting here, so you probably had 9 or 10 inches of snow. That's quite a bit of snow over there. So the GFS is hinting at a potential storm going up the coast, but being more off the coast. So Right. Okay, let me see if I can fit through here. Looks like I did. I was able to squeeze through. Despite my immense size, I was able to squeeze through a little gap. Whoops. There's a lot of melting and sublimation here. Can't really get any good measurements here. Just a bit. Ten inches of snow. It's probably what we got. Yeah, usually my street where I live is a lot better with wind. You're not going to get good measurements on Queens Boulevard because of all the strong winds that blast through here. So basically, hold on, I feel like there's something in my shoe. You got it out. The winter storm that hit last night was one of the biggest I've seen since 2017. Actually, it was the biggest I've seen since 2017. Since the 2017-2018 winter. The last two winters have just been horrible. Last winter, I only got 5 inches of snow. And the winter before was not much better with the biggest snowfall only giving us like 5 or 6 inches, which was in November. And the winter before that was not so good either because while there was a lot of storms, a lot of them missed New York City. And I happened to be in Florida when one of the biggest storms of the year hit, were the rare April snow that gave New York City like 7 inches of snow. That was the biggest snowfall in April in New York City's history in my lifetime, and I missed it because I was in Florida. Hold on. Okay. Yeah. This area isn't that good for measuring snow. There's too much wind in this area. Yeah. You might want to go, I might want to go in an area that's more sheltered from the wind, where you would get more vertical snow, not horizontal snow from all this wind. So the new BMW came out the other day, the iX, which is an electric BMW that has a range of 300 miles. This BMW costs $70,000, which is roughly close to the same price as the Model S. But considering it only gets 300 miles in range, which is a lot less than the Model 3 Range Plus, costs a lot more than that and gets less range. It's only expensive because it's a luxury car. If it wasn't luxury, it would probably cost around $30,000-$40,000. If it wasn't luxury and wasn't high performance. For example, you can get a 268 mile range or 260 mile range Kona EV from Hyundai or the Chevy Bolt for around $30,000 and get almost the same range, only 40 miles less. And that's a savings of what? $40,000 and only 40 miles less range. That's literally, you're paying $10,000 extra dollars for each 10-mile increase. That's like an increase of 1,000 miles per 1 mile of range. That's basically completely ludicrous if you ask me. I'm not saying you shouldn't buy the car. I'm just saying that, it's really expensive to be getting such small range. I mean, like the Tesla Model 3, for example, gets a lot more range than that and has the same price. It basically has 40 mile more range. If we are to combat climate change, we have to make high range, good quality cars at a cheap price that everyone can afford, especially middle class people like myself. Actually, I'm not middle class. Poorer Americans like myself who just maybe want to lease a car. Or there's a lot of cheap electric cars out there. I found a Nissan Leaf, for example, that costs only $30,000, like $8,000, and has very low miles. These cars are readily available. Nope. You can buy. Go on justcars.com and you'll see all those used cars. This is not a promotion. I'm just saying that for those people who want to drive electric and drive cheap, they can do it, especially with the used electric cars. But the thing is, the electric capacity decreases significantly once you drive a lot. Oh, look, the warm exhaust from the laundromat, look, from the dryers, look, it melts the snow up. That's basically, you have a localized Chinook wind here, look. See? Chinook is basically a snow eater wind that comes down from the mountains. So this is basically a Chinook event, small one. It's right here. You want to know what Chinook winds do when they blast out of the mountains and warm up into the 50s or 60s? That's what they do. So you eat the snow up. It basically evaporates and sublimes the snow. Sublimation is when snow or ice goes directly from being a solid to being a liquid, to being a gas. Not even melting. Snow sublimes and melts. Same with ice. Snow can definitely sublime at sub-freezing temperatures, while it melts at above freezing temperatures. That's why even when it's really cold outside, you can get snow to melt, to sublime and evaporate right from being a solid. So, well, I gotta go right now.